All right, you guys. So, when we left school, we had already done these examples on logarithmic functions on 5-2. So, I want to go over those really quickly because it's been a while since we've done them. So, this base becomes the base here. This guy that was in their own room gains status because they become the crown. And this one that was already big gains status because it gets its own room. Okay, so there's a formula that you can go and memorize. Or you can do the hierarchy raise, or you could do the little dance. There's a couple of people who are like, oh, I see a triangle here. And they went and followed that triangle again. Whatever way helps you remember it. So, let's go again. I have my base of 9. I have my exponent, my crown of 1/2, an equal sign, and then a 3. Remember that 1/2 signifies a square root. Okay, so I have my base 10. I have my answer of 1,000, 1 over 1,000. Which means that my exponent should be a negative number because my exponent should be taking this into a fraction, and a bar creates a bar. And then that 3 was there to create the 3 zeros. So remember that negatives create fractions. Okay. So now we want to change from exponential form backwards. So all of these are going to have the word log in them. They're all going to have an equal sign, so I'm going to go put all of those. And then I'm going to use the same colors from above, so I'm going to leave an example up from above. So my blue is going to be my base. So I get a base 2, I get a base 27, I get a base 4. Okay. Then my exponent, my crown that ruled the kingdom, had its own room originally. And then my big number stays a big number. My big number by itself stays a big number. Okay. So, I know that I also did these from left to right when I was in school. So I was like, hey, it goes the 2, then the 16, then the 4. It goes the 2, then the 16, then the 4 is up high. So there's a couple of choices there. Okay. Then they give you a whole bunch of things over here where they want you to go and evaluate. So the first thing we need to do is we need to plug and chug. So I'm going to go write log and an equal sign. I'm going to keep my base blue. And I'm going to change this into an exponent as we go. So this is going to be base 2. And then when x is 32. The 32 goes there. The 32 goes on the other side of my equal sign if I'm talking about an exponent. So what's missing right now is this exponent piece. And it's easier to get this from the exponent side than it is from the log side. So now what I'm going to start to do is I'm going to start to write 2 out. 2 times 2 is 4 times 2 times 2. That's 4 again. These make 16. And I know that 16 times 2 makes 32. So this is 1, 2, 3, 4, 5 of them. I need 5 2's. Okay, so all I'm doing is my own little method of adding 2's on. Some teachers go and do 2 times 2 is 4, times 2 is 8, times 2 is 16, and they do it one at a time. I tend to start out with the pairs and try to do as many pairs as I can first. Okay. So we're going to do this again. We're going to go plug and chug. So I'm going to go draw my log and an equal sign, and I'm going to go draw an equal sign over here to make it exponential. I'm going to put my blue base of a 3, and that's my base for both the log and the exponent. Then I'm going to plug this x in, and when I plug the x in, it goes here in this space, and that space moves up by getting its own root. So then what's missing is my exponent, or what's right here. And so I need to know, what do I need to do to the 3 to create a 1? And this one's a rule. It's the anything to the power of 0 is 1. So this should be a 0, and that should be a 0. Anything to the power of 0 is 1. So I've got some more examples. I've got a log right here, an equal sign. I need an equal sign. I need my blue base, 4, 4, 4. I need to plug that 2 in where it goes, and that goes over here on this side. And then I'm missing my exponent. So I need to get 4 to an exponent equals 2, and that's a lower number. And that's a hint that I'm going to need a square root in some way, shape, or form. And it is, in fact, a square root, and a square root is the same thing as 1/2. Okay? So when you do this on Delta Math, you're going to get y equals 1/2. And they won't even have you type in the y, they'll just have you type in 1/2, because that's the missing piece. Okay. So then I have log, a base, an equal sign for my exponential. So blue is my 9, that's my base. Then if x is 1/81, then my answer ends up being 1/81 over here. This creates a fraction. A fraction should tell you automatically that your exponent is going to be a negative. Okay? And then what do I do to make the 9 into an 81? I need a 2. I need 2 of them. I need 9 times 9. So this is -2, -2. So properties of logs. So anything at all, anything at all. And let me go back and change my colors. anything at all to the power of 0 equals 1. So anytime you see 5 to the 1 in your log base, you should be getting a 0. Anytime you see a base and a 1, you should be getting 0. Because anything to the power of 1, to the power of 0, sorry, is 1. Okay. So then I have this going on. And it's like, anything to the first power is itself. So if I have 3 and 3 right here, I get 1 as my answer. So if I have x and x, I get 1 as my answer. And this again is the shortcut. Anything to the power of 1 is itself. So then I get some craziness going on. So the colors are really super important. I'm not using the colors just because the colors are actually really super important. So my 4 is my base. Then my x right now is my exponent. Then I have an equal sign, and it clearly turns out to be that a to the x. So here, I don't know this right now, but I know that it equals 4 to the 3x. So now I know that that 3x goes in this box. So I get 3x as the answer. The log rule here that people like to abide by. The log rule here that people like to abide by is that the 3's cancel into a 1. Is that the 4's cancel. Okay. So the 10's would cancel, and I get x squared. Okay. So this, however, does not work. Okay. That's a weirdo schmeardo rule, and we'll get to it later. Okay, but that does not equal because this is on the outside. And on the outside, it does something different. So, I think we've done enough for today. I want to stop there, and I want to give you a Delta Math. And I know that we've already done this, but it's been about a week since we've had instruction. So I want to make sure that we are caught back up. And then on Friday, I'll have office hours, and you'll log in and we'll do things live. And then we start back up again on Tuesday.